Next up, Section 3, Heavy-Duty Roller Bearings. When the work order demands heavy radial and impact loading, spheres just aren't going to cut it anymore. We step up to cylinders or cones. This gives us a much larger line of contact to handle massive forces. Double-row cylindrical roller bearings offer amazingly high radial rigidity, which makes them perfect for high-speed, heavy-duty precision machine tools. Tapered roller bearings, on the other hand, are engineered so the outer ring, the inner ring, and the rollers all feature distinct coned surfaces. This tapered design is exactly what you need to handle a punishing combination of heavy radial and axial forces all at the same time.
Now, if you're sizing these up for a new machine build, you can't just eyeball it. You absolutely have to verify your dimensions, the bore, the outside diameter, and the outer width, to make sure they perfectly match your housing. But more importantly, you have to cross-reference the dynamic axial or thrust load, the dynamic radial load, and the rated speed in your data tables. If you get the math wrong and exceed those dynamic load limits while the machine is running, catastrophic failure is pretty much guaranteed. And paying attention to those load capacities is vital because these heavy-duty components do the heaviest lifting in our modern world. Compared to those tiny dental drills we mentioned earlier, the sheer scale here is just massive. These bearings are the absolute backbone of aviation, cargo systems, gigantic industrial engines, heavy agricultural equipment, and even the rotational tracking systems on large-scale solar panels.
All right, Section 4, Axial Thrust Loads. So what happens if the force is pushing directly parallel to the shaft rather than perpendicular to it? Notice how the geometry is totally reconfigured here to handle that. This diagram of a ball thrust bearing perfectly shows the specific orientation. You can easily spot the bore, the outside diameter, and the overall width. By sandwiching the rolling elements between two washer-like grooved rings, it lets the parts rotate while supporting a massive axial load that runs straight down the parallel line of the shaft.
So where do we actually see these parallel forces out in the wild? Well, you'll see thrust bearings taking the brunt of the force in the main rotors of radio-controlled helicopters or sitting at the base of radio antenna masts to reduce the load on the rotator. But probably the most common application? Every time you shift gears in a manual car. Thrust bearings are essential for your forward gears, and there's a very specific one called the clutch throwout or release bearing sitting right inside your...
Thank you for viewing so far. If it gives you some information, hit the like button and subscribe for more such technical learning.